Hey guys, it's been a while. I thought I'd quickly send you an update before I get too far ahead and I run out of things to describe to you. I've just literally been going nuts and in pretty much every spare moment that I have been working on this little guy. So there's two things to talk about here. The first one is obviously it's the drive motor test unit for Cubie-Pie. So I've got the new controlled motors, these 50-to-1 ratio motors, all hooked up, which is sweet. The sad part is one of them does not function very well, but it doesn't seem to hold back the bots, so I'm not too concerned. And the lead time to get a replacement unit is like 3 weeks, so CBF, I'm just going to use it for the moment and then I'll fix it later. The second thing to talk about here is what you're actually looking at, which is my new prototyping rig. So I sent you guys a photo. I created this model, which is just essentially a suite of 3mm holes at 10mm intervals in this axis and at 20mm intervals in that axis. And it just allows me to create little module clips and sort of connect things and create structures without having this kind of a nightmare, which is just shit hanging loose all over the place. So having this kind of rigid frame to build things on allows me to have things dangling and not worry about it. So so there's a lot to talk about here. That one is one of them. You'll be seeing some changes to that as I obviously make. Everything has its own bracket, which is great. I can just worry about creating a specific bracket for the individual components and not have to worry about how they actually fit in. This is obviously not Cubie-Pie. This is just a test rig. So this is bigger than Cubie-Pie. Cubie-Pie will actually be somewhere around there in width. This is about 19 centimeters in width and about 17 centimeters in depth. And obviously the full dimensions of Cubie-Pie is 150 by 150. So Cubie-Pie will occupy less space than this. And obviously the wheels are inset in Cubie-Pie within the structure itself. So this is purely a test rig so that I can calibrate the motors and do my coding and bits and pieces that I need to make the whole thing work. And on this rig there's a couple of new additions that we didn't have before. So the first one is the power boost adapter. This bad boy here will allow me to output oh god, I can't remember what the constant output is, but it should be enough for the robot. I'm a little bit worried when there's a lot of stall current going on these motors. There's a lot of current draw, which we have to monitor and figure out whether or not it's capable of doing it. But at the moment, it's great. It charges this 2200 milliamp hour battery when it's plugged in, and it automatically switches to the battery when the USB is not plugged in to then power the remainder of the circuit. So that's all really cool. So if I unplug this USB here and turn off the disable pin, then everything goes live, and she's hot and she's ready to drive. I'll turn that off for the moment. The other aspect of this, which I'm not satisfied with, is this current monitor. So this is a 30 amp max current monitor that outputs a voltage level between 2.5 and either 5 or 0, depending on how much current is flowing, positive 30 amps or negative 30 amps. So you basically say, right, well, 2.5 volts as a level on this output means that there's no current flowing. 5 volts as an output on this level means that there's 30 amps flowing, and negative 5 volts on here, and 0 volts on here means there's negative 30 amps flowing. That means that within 2.5 volts, I have to measure that micro millivolt differential and then do some math to convert that and to figure out how many amps are actually flowing. And I chose the wrong unit here, clearly, because the problem is that voltage is way too small for my microcontroller to measure cleanly, and it's making it very difficult to get an accurate reading. I'm just not skilled enough in all of the math, especially since I have to do some conversion because this outputs a 5 volt reading. This has 3.3 volt pins, which means I've got to have some voltage divider logic going on over there to get it down to 3.3 volts in the moment, which means you get your margin of error with your resistors, and then it's all too hard. Forget it. So I've got a new current monitor coming in, which will communicate via the microcontroller over I2C. So it controls the readings, and it just goes, yeah, it's 1.2 amps is being drawn at the moment, and it'll send that via a data pin to the microcontroller, which we just interpret literally as a data signal, which is much more accurate for me, given my limited understanding of all of these things. The only other thing that I'll talk about here is just, my hacky attempt to limit any throwback or flyback. Just focus the camera on that. Any flyback current from the motors when they're stopping and starting. I don't need that. I was just trialing it. Each motor has got its own control board, which has its own flyback diode, so I don't have to worry about any charges flowing back to the microcontroller. I was just noticing at the time that when I was changing from forwards to backwards quite quickly, the low battery light on the charge board was coming on, the indicator. So I was worried that there was some rogue pulses coming, somewhere. And the other thing that this does is I've got my battery level voltage monitor. So obviously, being that the batteries are a 3.7 volt lithium ion polymer battery, the maximum charge that the battery can hold is 4.2 volts, and I measure between 0 and 3.3 on the board. So I've got a voltage divider here, and I've got this hooked up directly to the battery charge. So at any point in time, I can monitor how full the battery is. When that battery charge drops to 3.2 volts, then it's low. And then when it drops to 3 volts, the whole system has to be able to turn itself off. So without the battery, because the battery's got an over discharge protection circuit inbuilt, without waiting for that to fire, I want the microcontroller to be able to identify that low battery and shut itself down, gracefully, essentially. So that is that. I've got this connector here just so that I can monitor the current externally. So I've got my multimeter I can hook up in series here and just see whether or not my current reading on my app matches the current reading coming from the circuit. But obviously, you guys want to see this thing drive, right? Well, I'm actually going to have to change cameras for that because as I've spoken about before, I'm using Blink as the control system, and Blink just happens to be installed on this phone that I'm filming on. So I'll get the other camera hooked up at some point in the near future, and I'll show you guys how all the controls work. So, this sort of represents maybe almost a quarter of the control systems for Cubie-Pie, because we've got obviously the lift mechanism, which I've done a video on previously, which lifts the wheels up and down. We've then got the servos which tilt and pan the head, and then we've got the input buttons for programming and the eyes for display. And then I think, guys, if we want to put that tail in at some point as well, which is just a simple servo too. So at that point, I think I'm going to be completely maxing out my DPIOs there, because the servos take up quite a few as well. But it's coming along. We're almost at the point where we can start building the frame and start connecting these things up properly. I need to do all these test circuits because I'm going to have, obviously I can't have all this bloody, afro wiring going on inside the bot. So I'm going to have to create some perf board circuits and do some soldering at a much smaller level. So getting all these circuits sort of configured in place is definitely what I have to do first. And then obviously knowing how much real estate these things, because if I'm going to replace this component, I need to put a different component. Knowing how much real estate all those things takes up when we actually go with the final components is crucial for coming up with the correct model as well in the right dimensions. So yeah, I'll do another video at some point when I get a chance in the next day or so of the bot driving around and the control systems and the feedback, and I'll post that later. Cheers, boys.